Welcome to the Wine Math series. My name is Erin Norton, and in this video we'll be going through some calculations for potential alcohol percentage. If you would like to skip the detailed explanation and head straight to some examples, you can move ahead to the time points that are listed in the video description below. Let's get started. So during the growing season, we grow our grapes, and during that time, the sugar concentration within the grapes accumulates. So our sugar concentration increases. And that sugar is released when we press the grapes or crush them and prepare the juice. And so this sugar that we worked really hard at developing all summer, we have that in our tank in our juice, and we add some happy little yeast, and we go through our alcoholic fermentation. And so during the alcoholic fermentation, we are producing alcohol, and in this case, the particular alcohol is ethanol. And there's a couple other products that are being produced as well, and they are CO2. And the last product that is produced and typically dissipated is heat. So just remember that yes, the point is that we are converting or we're having the yeast convert sugar into ethanol, but there are some other byproducts that we do get out of this process. Okay, so during alcoholic fermentation, we start off with glucose and fructose. That is the sugars that we're going to use from our juice, and they get converted into a molecule called pyruvate. And this, we're not going to go into the details of how we get to pyruvate, but this is a process known as glycolysis. And this is a process that happens in our human cells, and so we're very familiar with it, and we know that this is a 9-step process. And once we get to pyruvate, yeasts do something a little bit different than a human cell would do, and they go through alcoholic fermentation. And this is a series of reactions that is actually just 2 steps to go from pyruvate to alcohol. So we know that when we want to go through alcoholic fermentation, we typically see that we start off with about 18 grams per liter of sugar, and that gives us about 1% alcohol in the end. And I just want to point out that this is an empirical relationship, meaning that it was developed over time, and as scientists and winemakers and other fermentation scientists, they saw that this was in fact the relationship that we see when we do a fermentation. So a couple of notes on units. So degrees Brix is typically the unit of sugar that we measure in our grape juice. And degrees Brix, just so that you understand where how that relates to sugar, 1 degree Brix equals 1 gram of sucrose, okay, in 100 grams of liquid. Okay, that's the definition of a degree Brix. Okay, there's also the Baumé scale, which is used in some regions around the world, and this is actually a density scale. And the thing I want to point out at this point with Baumé is that the Baumé of distilled water, okay, because is 0. Okay, we're going to come back to Baumé at the very end and see how it relates to percent alcohol. So let's get started with a calculation to go from our sugar into a potential alcohol at the end of a fermentation. So we're going to jump right in here, and we'll start with, we're going to assign a degrees Brix that would be typical for grapes at the end of the growing season, and that would be, let's say, 20 degrees Brix. A little on the low side but in cooler regions, this is very possible. So I want to remind you what degrees Brix is again. So it's 1 gram in 100 grams of liquid. And in this case, we're actually quite lucky because we know that 100 grams per liquid, when we're talking about density, or when we think about density of water, because these solutions are in water, 100% water at this point, we know that 100 grams of liquid is 100 milliliters. So this is quite convenient that we can automatically work in milliliters when we're doing these calculations. So the first thing that we need to do is calculate the amount, the concentration of sugar. And then once we know the concentration of sugar, we can calculate the potential alcohol. So we are going to start off with, we need to get to this grams per liter of sugar. And so we're going to start off with this conversion factor that we've got up here, okay? And we know that 1 gram, okay, is per 100 milliliters is the same as 1 degrees Brix. Okay, so this is considered a conversion factor, okay? And we're going to multiply that at this point by our degrees Brix, okay, by our 20 degrees Brix. Now the last thing you may notice is that we have milliliters in our example here, and we want liters in our final calculation, or in our final value. And so we're going to multiply this by a conversion factor to get rid of the milliliters and change it into liters. And so we're going to multiply that by 1,000 milliliters over 1 liter. Okay, if you need help with conversion factors and unit analysis like this, we do have another video in this series where we jump into that. Okay, so now we're going to make sure our units all work out so we can cancel our units. Make sure you never cancel out your numbers, just the units. So milliliters here and milliliters here, and that will leave us with grams per liter. We go ahead and we compute this out, and we get 200 grams per liter. Okay, so that's our sugar concentration. Now we're going to move ahead and calculate our percentage alcohol. And you may wonder what the V by V means. And that's a volume by volume. Okay, and so we're not going to get into that. Again, I would check out our units video, and I will be explaining what volume by volume means in terms of percent alcohol. Okay, so in this case, we know that our conversion factor is, and again, this is an empirical conversion factor. So 1% alcohol is what you get when you have 18 grams per liter of sugar. So proportionately, how much alcohol should we get if we have 200 grams per liter? So we're going to multiply this by 200 grams per liter. And we're going to do a little unit analysis here, a little unit cleanup. Don't cancel the numbers. And we end up with 11.76% alcohol. Okay, so if you have 20 degrees Brix, you should have approximately 11.76% alcohol after the fermentation is finished. Not going to be exact, depends on a lot of factors going on in your fermentation, but that's what you can expect a value around. Okay, so let's do another example here. And this time we'll increase the amount of Brix, okay? I just want to show you how the percent alcohol changes as the Brix changes. So we're going to assume 25 degrees Brix here. And we're going to set this up in the exact same way. So we're going to calculate the grams per liter first of sugar, and then we'll calculate the percent alcohol. So I'm just going to make a little note here that we're looking for grams per liter. So we know that 1 gram per 100 milliliter, okay, it's the same as 1 degrees Brix. Okay, we're going to multiply that by our 25 degrees Brix. And again, we're going to take care of our milliliters here. 1,000 milliliters is the same as 1 liter. Clean up our units, milliliters, milliliters, Brix, Brix, and we're going to be left with grams per liter, and that will work out to 250 grams per liter. Okay, you may be seeing a pattern here that to go from Brix to grams per liter, you're multiplying by 10. Okay, and so percent alcohol at this point, so percent alcohol, volume by volume. We know that 1% alcohol is made when you have 18 grams per liter of sugar. We're going to multiply this by our 250 grams per liter. Clean up our units. And we will get 14.7%. So when we had 20 degrees Brix, we had about 11.8% alcohol. We upped that by 5 Brix, and we've got an additional couple of percentage points of alcohol. Okay, so lastly, I just want to point out that a lot of you may know that there's a simple calculation you can do where you just multiply your degrees Brix by a conversion factor that, but you might not know exactly where that comes. And it can be anywhere between this 0.55 to 0.58 is what I've heard in the past. Okay, so I just want to show you where that actually comes from, because I think that's useful to understand that we are actually doing that in those calculations that we just performed. We are determining this, this 0.55 to 0.58 factor. So in this situation, we don't know what our degrees Brix is, okay? So we're going to call X equals our degrees Brix. So let's go ahead and set the calculation up like we did before. So 1% alcohol divided by 18 grams per liter of sugar. Okay, we're going to multiply that by our 1 gram per 100 milliliter. Okay, is 1 degrees Brix. So just bear with me here. And multiply that by our X degrees Brix. So whatever the degrees Brix happens to be of our juice. Okay, the last thing, what we just need to do is clean up this 100 milliliters to get it into liters. So really what we just did here is we combined the two calculations together. So let's clean up our units. We've got grams and grams. We've got milliliters and milliliters, liters and liters, okay, and Brix and Brix. So we are going to end up with this percentage. So that's good. And so what this ends up being is 0.56. When you compute this all out, you get 0.56 times X. So that's whatever your Brix is. And that is your percentage alcohol. Okay, so that's where it came from. It's really about putting those two calculations together. So lastly, I just want to point out a couple of quick notes on the units of Baumé and Brix and how they are related. So 1 Baumé, okay, is the same as, and you can look this up on the internet, so is the same as 1.8 degrees Brix. Okay, so hopefully you're seeing a little pattern here. And this is the same as we know 18 grams per liter of sugar, which we also know is 1% alcohol. Okay, so conveniently, if you do end up working in Baumé, 1 degree Baumé equals 1% alcohol. So Baumé is essentially a scale, a density scale that does measure your potential alcohol directly. Okay, so it can be quite useful. Okay, and I think that's about it that we for potential alcohol calculations. So thanks for watching this wine math video. If you have any questions regarding the math or the general wine topic covered, feel free to reach out to us at wine@iastate.edu. Check out the other wine math videos to improve your math skills in the cellar. Cheers!